High-speed steel bits come in many types for a wide range of applications. New bits have a protective sheath like this one. Before using the bit, remove this sheath. Next, grind the end-wrap bit using a grinder. Wear correct protective gear when using the grinder. Use bare hands to avoid being caught in the grinder. Grind the bit according to the application, maintaining a sufficient clearing angle. Apply water from time to time to prevent burning. Use the corner of the whetstone to form a chip breaker. The bit surface is still rough after grinding with the grinder, so next, use an oil stone to form a sharp, smooth blade. Now let's start the actual lathe work. First, center the bit. Align the height of the center with the surface gauge. Then adjust the bit to the same height. When adjusting, make sure the blade tip does not extend too far out from the tool stand. Just 1.5 times or twice the shank width is fine. Insert the boards and adjust the height, using as few boards as possible. Fix the bit as close to the shank center as possible with a uniform pressure. Watch the angle of the bit to the workpiece. Using a 3-clod chuck, cut the mild steel pole. To cut the ends, pull the work out a bit from the chuck and tighten it. As the figure shows, the cutting process is governed by 3 factors: the cutting speed, the feed rate, which is the amount of tool movement for each rotation of the spindle, and the depth of cut, which is the depth to which the work material is cut for each rotation. Perform rough machining of the ends. The bit used is a right-hand bent tool bit. The rotation speed is 320 RPMs. Feed is manual feed. To prevent being hit by cutting chip, stand in a safe position when cutting. Now it's time to finish the ends. The bit used is an offset tool bit. Adjust the bit so it touches the workpiece horizontally. In the finishing cutting, the rotation speed is low and the depth of the cut is shallow. Because we're using a high-speed steel finishing bit, the rotation speed is only 40 RPMs. When using a high-speed steel bit, apply lube oil to improve the finish and the working life of the bit.
To cut long blades, be sure to perform center drilling. You will need to attach a center drill. Drill a hole in the center with the rotation speed at 320 RPMs. Make the hole about a third as deep as the length of the tapered end of the center drill. To perform center drilling, mount the bit on a center lathe. To extend the workpiece out further than the chuck, change your grip on the workpiece. Now we'll perform rough machining of a cylinder. The bit used is a right-hand bent tool bit. The rotation speed is 320 RPMs. Feed is automatic. To finish the bit to the rated dimensions, a microcollar is used. First, measure the present dimensions of the workpiece. If they are close to the rated dimensions, you can change the bit into a finishing bit. To adjust the microcollar of the lathe to 0, first make a shallow cut. Stop automatic feed. Set the microcollar to 0. Pull the bit and manually return the tool stand. Measure the diameter of the workpiece. Using the microcollar to keep an eye on the remaining margin until the rated dimensions, continue feeding and grinding. Prepare for gas welding by opening the oxygen and acetylene valves. First, open the oxygen valve. Be careful. The pressure in the oxygen cylinder is extremely high. Be sure not to lean against the pressure regulator. Keeping your body well away from the pressure regulator, open the oxygen valve fully.
The pressure inside the acetylene cylinder is low, so give the valve a half turn or single turn. The pressure used is determined by the thickness of the material used. In this case, you are using 2 mm thick mild steel plate, so the oxygen pressure should be 0.2 megapascals. The acetylene should always be at 1/10 of the oxygen's pressure, which in this case is 0.02 megapascals. Be careful that the acetylene pressure never exceeds ambient atmospheric pressure. Before connecting the blowpipe to the hose, check the suction of the injector. First connect the oxygen hose to the blowpipe, then open the acetylene valve slightly. Next, open the oxygen valve slightly. Place your fingertip over the suction inlet to check the suction. If the injector is working correctly, close the valves and attach the acetylene hose to the blowpipe. Attach the nozzle to the blowpipe. Different nozzles are used according to the thickness of the material to be welded. In this case, the material is a 2 mm mild steel plate, so a number 200 nozzle is used. Before starting welding, put on your safety gear: welding shoe covers, apron, gloves, and safety glasses. Ignite the blowpipe. Acetylene is a combustible gas. Open the acetylene valve slightly, then ignite the blowpipe using a dedicated lighter. Next, quickly open the valve for the oxygen, which assists combustion. Adjust the flame to a neutral flame. To extinguish the flame, shut off the oxygen, then quickly shut off the acetylene. Now let's practice making a downward welding bead. Holding the welding rod in your left hand and the blowpipe in your right, form the weld from right to left. First, make a neutral flame. Melt the base metal 2 to 3 millimeters from the tip of the core. When you have a molten pool of melted base metal, perform the weld by moving the welding rod slowly through the pool from right to left. Move the welding rod around slightly in the resulting gas, using a consistent rhythm to form a uniform bead width and height. Next, we'll make a downward butt weld. Make a series of 2 mm grooves, tack welding in several places according to length. As with the beading practice, first form a molten pool in the base metal, then melt a path through it with a welding rod. Use a brass rod to solder mild steel plate and copper pipe. Because soldering does not involve melting the base metal, you don't need to make a neutral flame as for welding mild steel plate. A little excess acetylene flame or carbonization is no problem. When applying the flame, be sure to heat the two metals uniformly so as not to melt the base metal. When using a T-type joint such as this, apply upward, side, and downward silver brazing to the copper pipe. Before starting, calculate the outside diameter of the pipe, inside diameter of the T-type joint, and the penetration of the insertion volume, so you use only as much brazing as you need. Calculate using a gap of 0.1 millimeters. Before starting the silver brazing, apply flux to the area to be brazed. We'll start with an upward brazing. You can tell the correct brazing temperature by the change in temperature of the flux. When flame is applied to the flux, it turns a dry white, then clear, then light brown. The correct brazing temperature is the one that creates this light brown. Perform brazing. This is a blowpipe used for cutting. Here also, check the action of the injector before fitting the acetylene hose to the cutting blowpipe. Adjust the flame so that the flame core looks like this. This valve provides the oxygen for cutting. Leave a gap of about 3 millimeters between the tip of the flame core and the base metal and preheat the base metal. When the base metal is red, open the oxygen supply and begin cutting. Now we'll describe the arc welding process. Be sure to wear appropriate protective gear for this work. Use the electrical current specified on the housing of the welding rod. Short-circuit the welding rod, then adjust the welding current using a clamp meter. Perform the adjustment by hand to set the correct current regardless of the length of the cab tire cable. The actual current will be about 10% lower than this value. Turn the current adjustment handle to find the desired current value. There are two ways of generating an arc: tapping and brushing. This is the tapping method. This is the brushing method. To create a string bead, hold the welding rod at a 10 to 15 degree angle to the direction of welding. Generate the arc about 10 to 20 millimeters in front of the starting point of the weld, then return to the starting point and perform welding. Check the bead width and height, as well as the undercut and overlap. Weaving beads are also formed with the welding rod at a 10 to 15 degree angle to the direction of the weld. The width of the weaving action should be 3 times the diameter of the welding rod, and it should temporarily hold the weaving at both ends. Check the bead width and height, as well as the undercut and overlap. For horizontal fillet welding, hold the welding rod at a 45 degree angle to each of the base metals. The welding rod should be at a 70 to 80 degree angle to the direction of the weld, with the tip of the welding rod just slightly touching the base metal. Check the bead width and height, as well as the undercut and overlap.